So, hello guys, I am back again with another good video. Today, I am going to discuss about asynchronous up counter. So, let me first tell you the definition of a counter. Counter is basically a device which counts, which used to count anything like the counting should be in ascending order, or it could be in descending order, or it could be a random sequence. Like if we are counting like 1 2 3 4 in ascending order, or we are counting in descending order like 5 4 3 2 1 0, like this. We can also count in random sequence, like after one, we could count like 1 3 5 6 19 0, like this is a random sequence. So if we count in a sequential manner, then we use asynchronous counter. Okay, so if we count in ascending order, it is called up counter, and if we count in descending order, it is called down counter. And if we count in a random sequence, um, we count it using synchronous counter. So in ACs or in stopwatches, we use counters. Like if we set the timer, and if we think about the that how could they count like 1 to up to a number. They count because they could count only because of counters, for the presence of counters. So or if we set the AC like this, that after 1 hour the temperature will be increased by 2 degrees, then how could the AC know that the temperature should be gained to 2 degrees after 1 hour? Because it has counter in it. So counter is basically a device which counts. Okay, so today I'm going to discuss about asynchronous up counter. So let's uh, start. Asynchronous up counter. Okay, so let us first draw the logic diagram. I'm drawing 3-bit up counter. Okay, 3-bit up counter. So this is flip flop 1, flip flop 2, flip flop 3. We are using JK flip flop, so we are naming this JK, JB, KB, JC, KC, like this. And as we all know, if a output is Q, then another output of the counter or the flip flop will be Q bar. So QA, QA bar, QB, QB bar, and QC bar. These are the outputs. And in asynchronous up counters or asynchronous counters, we use negative edge trigger. This is called negative edge trigger. This is clock. Okay, and for asynchronous up counters, for the next clock, the first clock should be given like this. Okay, and the next clock will come from the first output of the first flip flop. Okay, and the next clock will also be coming like this. Okay, the first output, from the first output we have to keep in mind this, mind that the clock or the next clock should come from the first output, and we have to give these two inputs. One, this will go from one input to another input simultaneously. um, and we will take the output from here. This is LSB and this is MSB. Now I know you guys are in doubt that why it is LSB and why it is MSB, because you will be knowing the logic, or you will be understanding it when we will draw the truth table. So let us first draw the timing diagram. Timing diagram. Okay, timing diagram. So as we are drawing 3-bit up counter, there should be 8 clock pulses. Okay, 4 7 8, 1 2 3 4 5 6 7 8. Now we have to just draw the lines like this. You should draw it using scales, but I'm drawing it using my hands. I know the lines are not accurate, but they are enough to you know show the logic. So as we have drawn negative edge trigger, so as we all know, a clock pulse has two triggers. This is positive edge trigger and this is negative edge trigger, and asynchronous counters work on only negative edge triggers. So we will put negative edge triggers here, and the first input is QA. Okay, as we know that asynchronous counters work on only negative edge triggers, so it will go up on a negative edge and go down on a negative edge like this. Okay, so this is a positive edge, so here it is going upwards, and this is a negative edge, and that is why it is coming down. Okay, so here for QA, this is negative edges. Okay, they are negative edges, so we will draw QB according to the negative edges of QA. Okay, so these are the pulses of QB, and these are the negative edges, okay, of QB, and QC will be drawn accordingly. According to the negative edges of QB. Okay, so as we all know, we have three outputs here: QA and QB and QC. Okay, so three outputs are drawn, and we will know the logic now, or the truth table logic of the truth table. Okay, so at first, if we consider a clock pulse, this is um, a clock pulse has two levels. This is low level and this is high level. So low level is also known as 0. Okay, so 0 0 0 in the first stage, and this is 1 0 0. Okay, next edge is 0 1 0, and the next edge is, as it is high, then 1 1 0, then the edge is again falling, so it will be 0 0 1, then the next edge will be 1 0 1, and for the next edge, as it is falling, then it will be 0 1 1, and finally, as all edges are high, then it will be 1 1 1. Okay, so now we will draw the truth table of asynchronous up counter. Okay, now we will derive the truth table. Truth table. So there should be 4 columns. Okay, one column should be of clock, and the next or the rest of the two will be QC. The first column would be QC, QB, and QA. Why should the first column should be QC? Because as I have mentioned here, this is LSB and this is MSB, so that is why the column name should be QC, QB, and QA, like this, and this is the first column should be clock. There must be 8 rows. Okay, 1 2 3 4 5 6 7 8. Okay, you can draw another clock, another 2, for better understanding. Okay, at first we can see that all values are 0 0 0. Okay, 0 0 0. So let us draw it like this: 4 zeros, 4 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 0 1 0 1 0 1 0 1. Okay, so if we now, this is the clock pulse is not given here, so this is first clock pulse, this is second, this is third, this is fourth, this is fifth, this is sixth, this is seventh, and the last one is not required. This one is not required, so you should draw 9 rows. Okay, each one will be 0 0 0, because if we see, if you follow the timing diagram, uh, the last stage is 0 0 0. The at last all levels are going as 0 0 0, so the last one should be 0 0 0. We will the counter will count like a ring. Okay, so again, after, at first it will start from 0 0 0, and at last it will move to 0 0 0. Okay, so the truth table should have 3 rows and 9 columns. Okay, so why it is written as 0 0 0? Now we will understand it. Because at first it is written as 0 0 0, because the all the levels are in low mode. Okay, and so if we uh, count upwards like this: QC, QB, QA, we have written QC, QB, QA, so we will count upwards like 0 0 0, then next one will be 0 0 1, it is written here 001. Then 010, it is also written 010. It is 011, then it is also coming as 011. Then 100, it is also written as 100. Then 101, it is also written as 101. Then 110, it is also written as 110. Then 111, it is also written as 111. At last, all edges are falling okay in low levels, so that is why we have written 000. Okay, so this is the logic of um, asynchronous up counter. Now I am finishing the video here. If you have doubts regarding this topic, you can let me know in comment box. I will try to solve the doubts of. So that's it for today's video. We will meet in another good video. So goodbye, take care.